Ancient advanced stonework and extreme machining in ancient Egypt. The purpose in presenting the notion of ancient advanced extreme machining in ancient Egyptian culture is simple. They had such a sophisticated stone technology beyond our own. The evidence presented here will leave you absolutely baffled beyond belief. There are so many numerous examples, we can only hope the scientific process in uncovering the work of the engineering geniuses becomes enhanced. However, Egyptology is no fan of attributing any advanced skills to the ancient master masons. They still sell us this method to achieve advanced results like this. The tides of injustice are slowly turning as global tourism and sophisticated cameras are commonplace now. We have hard evidence of pre-dynastic stone-turning possible lathe work, tubular drilling at advanced speeds, marks left behind by what can only be perceived as use of circular stone saws, mechanical methods of engraving lines in hard stones as far back as the 4th dynasty, ancient machining techniques comparable to today's CNC routing, except done in hard pink granites. The ancient Egypt masons shaped all kinds of stone with intricate mastery. They were adept with the use of a wide variety of manufacturing tools, various building stones, tube drills capable of hard material, straight cutting saws, circular cutting saws, lathes, and smoothing techniques for polishing. It's the marks left in the stone by these multitude of tools which are the reliable source of evidence of advanced extreme machining in the ancient world. There are no surviving examples of the tools utilized. There are no written or pictorial records discovered which mention or describe their use. After all, we barely do this today. Why should they in ancient times? There's serious debate about the nature of the tools and their advanced techniques in the historical framework. The marks left in stone are a beacon of curiosity and intrigue to engineers who work these materials today. Egyptology couldn't care less how they did anything unless they feel the need to show some guy pounding a rock and solve the enigmas of all Egyptian building work in an instant. Modern experts are baffled with their machining techniques, and it's these individuals we must listen to if we want to answer conclusively the key questions. What were the cutting tool tips made of? What was their abrasive? How were the tools manufactured? What machinery was used to control the cutting surface on the stone? How did they apply the tool pressure? Why were their tolerance standards of precision so high? Engineers and architects are completely puzzled and rigorously debate pointing to monuments and artifacts, though no scientific proof exists for any of their theories unless the tools are present. Look at an ocean cruiser. It doesn't take a sophisticated debate to know tools, industry, and manufacturing of a high level was used to create it. Why does Egyptology portray such ignorance on the issue then? Because the revelations bear directly on the developmental history and subsequent chronology of the pre-dynastic Egyptian cultures, followed by the early dynastic period. Ancient housewares discovered by Flinders Petrie show undeniable proof of being turned on a lathe. There are various examples in the Cairo Museum, the Petrie Museum in UCL London, and various other museums around the world. Some of the best examples of stoneware were discovered around the Step Pyramid at Saqqara. Petrie also discovered pieces of interesting stoneware on the Giza Plateau. There are incredible aspects about these vases, plates, and bowls that speak of highly advanced engineering techniques. They portray the distinctive tool marks belonging to lathe-manufactured items. This is easily visible in the center of the bowls or plates, where the angle of the cut changes rapidly. The stoneware in question is left with a very clean, narrow, and almost perfectly circular line made, a clear indication of the tip of the cutting tool. These stoneware masterpieces, comprising of dishes, platters, are some of the finest ever found, and they're right there from the earliest period of ancient Egyptian civilization. They're made from a variety of materials. Seemingly, the choice of material to be cut was irrelevant, as they went from soft alabaster all the way up the hardness scale to extremely hard granite. Working with alabaster is relatively easy, at least compared to granite. Alabaster can be worked with primitive abrasives and tools. The sophisticated workings in granite are an entirely different matter. and indicate a level of skill we're not aware of today and can only be considered advanced technology. Flinders Petrie was quoted on this issue saying, "The lathe appears to have been as familiar an instrument in the 4th dynasty as it is in the modern workshops." Stonework as sophisticated as these examples are not found in any later era, leaving many to think the skill was lost or that they were heirlooms from a different epoch or culture. There's also the case of delicate vases being made of very brittle schist, somewhat like a flint, and yet they're polished, finished, and turned to flawless thin edges, an incredible feat of engineering and craftsmanship. Many bowls are turned and hollowed out with thin necks and have a symmetrical wall thickness without any noticeable errors. Let us not understate that these items were made by an ancient machinist. To produce this in clay would be outstanding. To see it in granite is simply incredible. There are many pieces turned out of granite, porphyry, or basalt, all fully hollowed with decorative narrow undercut openings. The most remarkable of these have long necks. The fact remains we cannot replicate these artifacts today with techniques, crafts, or machinery. But before we feel any ineptitude of craftsmanship, Egyptology comes to the rescue with copper chisels and stone pounders. The tri-lobed schist disc of Sabu is a complete mystery and masterpiece. Some 24 inches in diameter, bizarre structure with extremely thin pieces turned out of schist. The large plate has a central hub some 3 inches in diameter. The outside rim, which in 3 areas spaced evenly around the perimeter, is flared towards the central hub. If there was ever a case for advanced ancient stoneworking, this is it. It's made from a very fragile material called metasiltstone. Bending this material without fracturing it would be hard even for modern technology. According to some scientists, the Sabu disc raises important questions about our view of history. What was the purpose of this mysterious disc? Why on earth would ancient Egyptians create such an intricate object? 5,000 years ago, people were not supposed to possess the necessary tools to work material like this. Why would ancient Egyptians go to all this effort to create the disc if it didn't have a specific purpose? The Sabu disc is the subject of wild speculations as a result from everything involving rotating energy to acoustic knowledge. There were not just a few of these stoneware items. Apparently there were thousands discovered around the Step Pyramid. The Step Pyramid is considered the oldest stone pyramid in Egypt. Although Petrie found some fragments of similar bowls at Giza, the majority have been found at the Step Pyramid, at least in quantity. Many of them have inscribed, actually scratched onto them, the symbols of the very earliest kings of Egypt from the time before the pharaohs. The primitive skill of the inscriptions provokes many to think those were not made by the same craftsmen who created the bowls in the first place. Perhaps they were added later by those who acquired them as heirlooms, is highly plausible. Who made these objects? Why? How? Where? And when? What happened to the master craftsmen? The advanced tubular drilling techniques. W.M. Flinders Petrie is by far an essential reading source on anything to do with tubular drilling in ancient Egypt. After all, he picked up the pieces, the drill cores, and the fragments that nobody else seen the value in. In 1883, he wrote the following words: "These tubular drills vary in thickness from 1/4 inch to 5 inches in diameter, and from 1/30 to 1/5 inch thick. The smallest hole yet found in granite is 2-inch diameter. There is a still larger example where a platform of limestone rock has been dressed down by cutting it away with tube drills about 18 inches in diameter. The circular grooves occasionally intersecting prove that it was done merely to remove the rock." Tube drilling was commonplace in Egypt, a wonderful pristine example of which is displayed in the Cairo Museum, with zero information or provenance. Clearly, the spiral grooves are visible. Not only are the spiral grooves of regular depth, but equally spaced all over the specimen. Where the cores overlap, the consistency is perfect. This can only be attained by jeweled points set into drills, which was Petrie's conclusion over 100 years ago. The enigma has raged since then. The most famous example of tube drilling by the ancient builders is the sarcophagus in the King's Chamber of the Great Pyramid. A tube drill mark was left on the top inside of the box with some extra polishing to cover it up. If you go to the King's Chamber, you can still see it if you examine the box. Looking at the radius of the cut in the King's Chamber box, less than 2 inches, it's rather obvious that in this one piece alone, the masons made thousands of holes several inches deep. The experts who did this had mastered completely the principles of drilling in any material, soft or hard, wood, stone, or metal, and could have drilled virtually any naturally occurring material on this planet. Things get interesting when we find holes drilled in granite, and we even have some of the drill core remnants. This can be seen in the overhead door lintels of the granite-lined Valley Temple near the Sphinx, and at Abu Gharaib. Most of the doorways in the temple still show evidence of tube drilling one way or another. Perhaps the holes were used to place long vertical rotating shafts on which the doors were hung, somewhat like hinges. There's a primitive version of tube drilling that can be achieved with a bamboo drill bit, a bow saw, and sand. However, achieving this method in granite is certainly not easy by any standards. Tube drilling is a highly specialized method that just wouldn't develop without the need for a large hole. These holes are the evidence of a highly advanced technology, and certainly not developed for just this one purpose, but for many easier purposes. Generations of development over many projects, over hundreds of years. When you get this far in the psychology of our ancient builders, you further realize none of this happened without mining and metallurgy. Bit manufacturing, generations of experience with grinding materials, rotational manufacturing techniques, the wheel, and all that goes with it. What was the dedication or motivation for this developmental procedure? And is there an archaeological record in pre-dynastic and Old Kingdom Egypt pertaining to advanced ancient stone-cutting techniques? Black basalt saw marks on the Giza Plateau and the King's Chamber. There are black basalt paving stones on the east side of the Great Pyramid at Giza. Most people walk over them, never realizing them, probably busy looking up at the Great Pyramid. These basalt pavers are irregular in thickness and often rounded on the bottom side. They were placed on top of blocks of limestone which had previously been fitted to the underbelly bedrock. Amazingly, the basalt blocks were cut to level in situ after they'd been put in place on the ground. The edges are so crisp and parallel. The quality of this work indicates that the blade was held completely steady. Apparently, cutting basalt was not so slow and arduous that extra cuts like these would have been avoided, as being an unnecessary waste of time. There are several places where overcuts like these can be seen. They show no trace of the wobbling cuts that might be expected of a long hand-pulled blade as it starts into hard material. That may be because these cuts were made as the blade was coming out of a cut above it, and it was held firmly in place by the rock above it. We know that the stone box in the King's Chamber of the Great Pyramid was cut with a very large saw, one which was longer than the box, perhaps 10 feet. The marks on the bottom of the box were discovered and described by Flinders Petrie. He also described an error in cutting that went off the mark before the workers noticed to back out the saw from the cut and start over. These questions could perhaps be answered if microscopic examinations of the cut marks by contemporary specialists in manufacturing technology could analyze it. The works of William Flinders Petrie pioneered this research in the 1880s. Petrie, in Egypt particularly, he showed there was an order or protocol for creating artifacts that involved the use of simple geometries, and such as simple radius over how radii are combined to create a shape where one radius would lead to another radius that would then be tangent with a flat surface. And you find that at Giza near the pyramids, and also other places around Egypt. There are so many remarkable artifacts that really have not received that much attention in conventional literature, and the simple methods that are described by Egyptologists don't really answer the question of how these artifacts were created, because it's not just a matter of describing a tool and how you actually remove material from a block of granite, but also a range of instruments that would have been necessary to ensure that the measurements are consistent throughout the creation of those artifacts. The tools to measure are equally important as those used to cut, drill, and polish. Those tools don't exist in the archaeological record, nor have they been even suggested in the conventional literature that they did exist. So it's an open question right now, and it's certainly open for study by Egyptologists or universities who would care or dare to take up the challenge. And that challenge is to be able to come up with methods that would explain these artifacts in a way that modern engineers would understand and believe. Unfortunately, in the past, this has not taken place. We've not been directed or shown by people in Egyptology or in academia. We haven't been shown any methods that will adequately explain the creation of these artifacts. For example, perfectly flat surfaces that you find on the igneous rock or the granite and basalt diorite artifacts that occur all over Egypt. You'll find a very large block in the Valley Temple near the Sphinx at Giza. There's one wall where there is a diorite block that shows a high order of precision, being extremely flat. Comparative measurements using a very precise straight edge show precision to 1/10 the thickness of a human hair. Whilst this is extremely precise, you also find those kind of surfaces in the Great Pyramid and the granite box in the Great Pyramid, also the Second Pyramid. There are numerous very large, what they call sarcophagi, in the Serapeum, and these sarcophagi are supposedly built to bury bulls. But the precision and the size of these boxes that seem to indicate a much higher purpose. One that would serve a technological purpose rather than just for a funeral, because on the inside of the boxes you not only find very precise flat surfaces, but also the corners where one surface meets another are extremely square. Also, the wall of the inside of the box where it meets the lid is extremely square. The fact that these artifacts and work materials exist has not been adequately explained in the literature we're trying to understand to really come to grips with. Egyptology isn't trying to come to grips with anything, even how we will create these artifacts today, because it would really stretch our capabilities to make these artifacts, particularly the ones in the Serapeum. But these are fairly simple geometries. We go from the simple to the complex, and then it becomes a little more difficult to explain, because not only a flat surface is fairly simple to understand in terms of how you would grind a surface flat now. When we move to more complex surfaces, we find that there are objects that have curved surfaces or radii, and gathering the information about those, I've tried to determine how they were created. And gathering the information about those, I've tried to determine how they were created. But before you can actually do that, you have to determine exactly what it is that you're looking at, and that you can't do that without taking measurements. So taking measurements of those artifacts. When you have complex compound surfaces and compound radii that flow from one to the other, and also they seem to follow a general direction, or the contours are maybe cut, and then that contour flows along a straight line, and that straight line on an axis is very precise, to almost as though it would be made on a machine. And that, of course, is a very controversial suggestion. In today's world, you have to consider that because the two created any other way, it would be enormously difficult. And certainly for an artifact that's supposed to be part of a construction, it wouldn't require that much of that high precision if it was just for our construction purposes. If it was made by hand, it would take an enormous amount of time for you to create that precision, and it wouldn't be necessary anyway. Those are the kind of questions that need to be asked when we look at these artifacts. It's a question of what tools would have been used to create it, and when we ask those questions, we tend to lean more towards the fact that the machines or the tools that they were using to create them were capable of no lesser precision and what appears in the piece. Flinders Petrie was very outspoken on these issues over a century ago, stating, "The methods employed by the Egyptians in cutting the hard stones, which they so frequently worked, have long remained undetermined. Various suggestions have been made, some very impractical, but no actual proofs of the tools employed, or the manner of using them, have been obtained." Amazingly, he recognized the immense importance by today's standards all the way back then. He gave detailed analysis of engineering enigma. The typical method of working hard stones, such as granite, diorite, basalt, etc., was by means of bronze tools. These were set with cutting points, far harder than the quartz which was operated on. The material of these cutting points is yet undetermined, but only 5 substances are possible: beryl, topaz, chrysoberyl, corundum or sapphire, and diamond. The character of the work would certainly seem to point to diamond as being the cutting jewel, and only the considerations of its rarity in general interfere with this conclusion. In Memphis, there's an open-air museum there with a statue of Ramses, which is lying on its back. One of the things that's looking down the length of the Ramses statue, the face seems to be extraordinarily regular and precise, and particularly the nostrils being identical on both sides, which is unusual to find somebody or some person with their identical nostrils. The ancient Egyptians were being very precise and symmetrical in the creation of their statues. In the Luxor temple, the head of Ramses on his statue is so perfect looking. How could anyone not find this puzzling? The famous author and manufacturing engineer Christopher Dunn, who's done so much to bring these enigmas to light, has shown the complexities of this engineering prowess. The symmetry in the Ramses face is very remarkable precision. Overlaying 2D transparent photos shows this amazing feat of engineering. When you realize it's 3-dimensionally symmetric, it becomes mind-boggling at that point. Christopher Dunn is by far one of the most prominent experts on this entire issue. The level of sophistication that the ancient Egyptians had used in creating these statues is simply incredible. The Ramses statue in situ at the Temple of Luxor is not a rogue example. Reportedly, over 100 Ramses statues were created. Another famous one is in the British Museum, and it's in the exact same condition of precision and symmetry. The interesting thing about the British Museum statue of Ramses, we see that there was a mistake in the manufacture of that statue, where there was a dig in the corner of the mouth where the tool had cut too deep. And then in order to compensate for that, they had to cut the lips deeper into the face, which created a very sharp cusp. Human hands really didn't have much control over because they did not have to do those mistakes by hand. Again, we return to Flinders Petrie's analysis for insight. Many nations are in the habit of cutting hard materials by means of a soft substance, as copper, wood, horn, etc., with a hard powder applied to it. The powder sticks in the basis employed, and this being scraped over the stone to be cut so it wears away. Many persons have therefore very readily assumed, as I myself did at first, that this method must necessarily have been used by the Egyptians, and that it would suffice to produce all the examples now collected. Such, however, is far from being the case, though no doubt in alabaster, in other soft stones this method was employed. Let us take a moment to recap what we do know, what we can ascertain or accept from what we know. They had tube drills with drill bits and the necessary machinery to hold them in place and apply rotational torque. They had saws that could cut granite with ease and precision, producing amazing symmetry. They had the ability to work the hardest of rocks, and more often preferred to do so. In addition, they applied their techniques finishing granite in situ, after a block had been placed in a wall or on the surface of a pyramid, which literally boggles the mind. They had the ability to cut, level, and polish granite to a sophisticated degree of perfection. They had lathe machinery that would turn and polish granite, schist, basalt, etc. in ways we've not duplicated in our modern society. They cut extremely accurate parallel limestone joints with such a remarkable flatness over huge surface areas, some 35 square feet or more, a technique they'd mastered before creating the casing of the Great Pyramid at Giza. They had the knowledge and technology to repeatedly lift, maneuver, and delicately place enormous weights of stone at various heights. They had the motivation and means to quarry and move millions of stone blocks. They had the administrative skill to foresee multi-generational works, all that they require for a very long planning and project continuity, whilst maintaining the commitment of many generations of craftsmen, from apprenticeship through retirement of the workforce. Putting it this way, The pyramid builders of ancient Egypt have achieved the implementation of the largest, most ambitious, and vast long-term engineering construction program in the history of mankind, by a long shot. Flinders Petrie never could satisfy his curiosity over the working of quartz, saying that the Egyptians were acquainted with a cutting jewel far harder than quartz, and that they used this jewel as a sharp-pointed graver, is put beyond doubt by the diorite bowls with inscriptions of the 4th dynasty, of which I found fragments at Giza, as well as the scratches on polished granite of Ptolemaic age at San. The hieroglyphs are incised, with a very free cutting point. They're not scraped or ground out, but are plowed through the diorite, with rough edges to the line. As the lines are only 1/150th of an inch wide, the figures being about 0.2 long, it's evidence that the cutting point must have been much harder than quartz, and tough enough not to splinter when so fine an edge was being employed, probably only 1/200th of an inch wide. Parallel lines are graved only 1/30th of an inch apart from the center to center. Dendera Temple provides the same baffling discoveries with respect to ancient stone cutting techniques and advanced machining in the ancient world. Just like the Luxor Temple, the consistency and repetition in geometries in the Dendera Temple are revealed when we study the Hypostyle Hall. This impressive structure, as you can enter the temple, contains 24 columns each, about 90 meters high, and they have a capital on the top which is 4-sided capital with 4 phases of the goddess Hathor. The capital columns in this Hypostyle Hall are all in alignment with each other in a very surprising and precise way. When we look at the geometric features of the capitals, even the ears of Hathor seem to be in alignment. There are many complex geometric elements at play with various overlapping ellipses, and this repeats on each face of the 4-sided columns. To imagine constructing this hallway with all these columns and capitals, when we consider that the height to which these capitals were placed and the potential for error and communication of error, how were they able to precisely align each of those features? Also, what we find is that the capitals are not in one piece. They were made in several pieces, and the builders were able to detect the split lines, were able to determine where those split lines were, then very precisely put it all together. The whole temple was manufactured very precisely before being erected and put into place for assembly. Egyptologists profess, at least on site at Dendera anyhow, to how this remarkable complex feat was achieved. As laughable as the following theory is, it's perpetrated repeatedly with zero knowledge of manufacturing procedures and blatant disregard for the evidence in front of them. Allegedly, the builders brought up rough blocks in mud ramps, placing the blocks on top of one another, and then starting at the top and chipping the material away, removing the sand or mud as they got lower and lower and lower, basically finishing their work on the way down. What that evidence really shows you is that is not the case. Everything was made perfectly well by hand and then assembled. Considering the extraordinary amount of work that went into creating the Dendera Temple, it's hard to imagine the preposterous scenario where primitive tools created such a marvelous wonder of craftsmanship. One of the biggest mysteries in Egyptology is if the textbooks on what tools were employed by the ancient Egyptians in the thousands of years that the ancient Egyptian civilization existed, some 3,000 years, you can follow the development of tools from the beginning of that civilization to the end, and we start out using copper chisels, stone balls, stone chisels, wooden mallets, and then 3,000 years later we're using the same thing. Yet if you look at the extraordinary sophistication and genius of the ancient Egyptian artifacts and temples, to think that those engineers were still not advanced in their stone tools in thousands of years or did not improve their techniques, it's counterintuitive to even consider it all. We must ask the question where the tools are. We know that they existed and that we just haven't found them yet. We know that they had engineers. We know that they had craftsmen. We can't deny that, and engineers don't just function that way. They'll make improvements to their processes in any generation. In any part of you that have people with engineering lines, they'll continually improve their tools sometimes very rapidly, but certainly over a 3,000-year period. Producing the level of work they did, something is obviously missing.